Have you ever wondered about the technology behind a gyro monorail? Indeed, it's a fascinating piece of engineering. The gyro monorail, also known as a gyroscopic monorail or gyrocar, is a marvel of engineering that marries stability and efficiency. This singular rail-land vehicle employs the magic of gyroscopic action to maintain its balance and stability. This technology, while simple in theory, is a testament to the ingenuity of its early innovators. The development of this technology is credited to three key inventors: Louis Brennan, August Scherl, and Piotr Szylowski. These visionaries laid the groundwork for the gyro monorail in the early 20th century, each contributing their unique insights and ideas to its evolution. Louis Brennan, an Irish-Australian mechanical engineer, was one of the earliest pioneers. His model of the gyro monorail was an ambitious project that caught the attention of the British Army and the India Office, both of which invested in his groundbreaking work. Parallel to Brennan's efforts, August Scherl, a German entrepreneur, was working on his own version of the gyro monorail. His model, though smaller than Brennan's, was an innovative approach to the concept of single rail transportation. Meanwhile, in Russia, Piotr Szylowski, a lawyer and inventor, was developing his own take on the gyrocar. His model exhibited some unique characteristics, such as asymmetry and instability during turns, which added a new dimension to the ongoing research. These early prototypes, while innovative and promising, were not without their challenges. They faced numerous hurdles, from technical glitches to financial constraints. Yet they paved the way for future developments that would eventually bring the gyro monorail closer to reality. While these pioneers laid the groundwork, it was not until the 1960s that a more functional model emerged. Before we delve into the American evolution of the gyro monorail, let's dive deeper into the technical aspects of this fascinating technology. The gyro monorail relies heavily on the principle of gyroscopic action. A gyroscope is a device that, once spinning, tends to resist changes to its orientation. This resistance provides the stability that a gyro monorail needs to stay upright on a single rail. Imagine a spinning top. Even though it's balancing on a tiny point, it stays upright as long as it keeps spinning. That's gyroscopic action in a nutshell. Now picture this principle applied to a monorail. The gyroscopes in a gyro monorail are powered, meaning they can spin continuously without slowing down, providing constant stability. The gyroscopes are strategically placed within the vehicle to balance the weight and maintain equilibrium. This is where the engineering magic happens. However, implementing this technology into a monorail system isn't as straightforward as it sounds. One of the main challenges is ensuring the gyroscopes are powerful enough to stabilize the vehicle, especially when it's carrying a heavy load. Another challenge is the issue of gimbal lock, a situation where the gyroscope loses 1 degree of freedom and can cause instability. These challenges, while complex, are what make the technology so interesting. Understanding the technical details gives us a greater appreciation of the ingenuity behind the gyro monorail. It's a testament to the inventiveness and perseverance of the engineers who have dedicated their lives to bringing this technology to life. Fast forward to the 1960s, the gyro monorail technology took a significant leap forward in the United States. This was a time of innovation and exploration, and the gyro monorail was no exception. In the heart of this evolution were three minds: Ernest F. Swinney, Harry Ferreira, and Louis E. Swinney. Their version of the gyro monorail was a bold reimagining of earlier designs. The trio aimed to overcome the shortcomings of previous iterations, such as the instability during turns experienced in Szylowski's Russian gyrocar. They sought to make a vehicle that was not only stable, but also nimble, capable of navigating sharp turns with ease. In their design, the gyroscopes were powered, a feature that was a significant departure from earlier models. This meant that the monorail could maintain stability without the need for a large, cumbersome counterweight. The result was a sleeker, more streamlined vehicle. But the road to innovation was not without its hurdles. A significant challenge was the need for powered gyroscopes in multiple cars. This increased the complexity of the design and the cost of production. It was a tough nut to crack, but it was part of the process. Each challenge brought them one step closer to the ideal gyro monorail. Despite these advancements, the gyro monorail was yet to reach its full potential. The technology was still in its infancy, and there were kinks to iron out, problems to solve, and efficiencies to find. It was clear that the journey of the gyro monorail was far from complete. The American evolution had brought it a long way, but the best was yet to come. Despite advancements, the gyro monorail still had a long way to go. By now you might be wondering, what makes the gyro monorail so special? Well, let's delve into the advantages and disadvantages of this intriguing technology. First off, the gyro monorail boasts some impressive benefits. One of its key advantages is its ability to suppress hunting oscillation. Now you might be asking, what on earth is hunting oscillation? Well, in the simplest terms, it's a wobbling motion that can occur in vehicles moving at high speeds. This oscillation can lead to increased wear and tear on the vehicle and its tracks, and can also cause discomfort for passengers. But thanks to the gyro monorail's unique design, this issue is significantly reduced, leading to smoother rides and longer-lasting infrastructure. Another advantage of the gyro monorail is its capability to make sharper turns compared to traditional rail systems. This can be a game-changer in dense urban environments, where space is at a premium and the ability to navigate tight corners can significantly enhance route flexibility. However, like all technologies, the gyro monorail is not without its drawbacks. One of the main challenges is the need for powered gyroscopes in multiple cars. These gyroscopes, which provide the stability for the monorail, require a significant amount of power to function. This means that the gyro monorail can be more energy-intensive and potentially more expensive to operate than traditional rail systems. Furthermore, these gyroscopes add complexity to the design and maintenance of the monorail cars. The more complex a system, the more potential points of failure, and the more specialized the maintenance needs to be. This could potentially lead to higher costs and longer downtimes when problems occur. Like any technology, the gyro monorail has its pros and cons, but the journey didn't end there. As we will see, these challenges did not deter innovators from continuing to develop and refine the technology. Stay tuned to learn more about the financial hurdles and setbacks, and how the gyro monorail evolved into its modern form. In the world of innovation, financial backing can make or break a project. Without a doubt, the gyro monorail has faced its fair share of financial hurdles. The journey of this technological marvel has been marked by a series of setbacks, primarily financial. The project, spearheaded by Louis Brennan, August Scherl and Piotr Szylowski, faced numerous challenges, with funding being a significant one. Louis Brennan, the genius behind the first gyro monorail, received initial funding from the Army and the India office. Unfortunately, his innovative model failed to attract further investment. This lack of financial support hindered the development and full realization of his groundbreaking design, leaving it a mere prototype. In Germany, August Scherl took up the challenge of creating a gyroscopic monorail. His model was smaller than Brennan's, but it too faced a similar fate. Despite its potential, Scherl's gyro monorail struggled to secure the necessary funding to propel it from the prototype stage to a full-fledged transport system. This financial hurdle proved to be an insurmountable obstacle, halting the progress of Scherl's project. Across the globe in Russia, Piotr Szylowski faced similar financial challenges. His gyro car, though a promising concept, exhibited asymmetry and instability during turns. These technical problems, coupled with the lack of substantial funding, resulted in the project's stagnation. It's clear that despite the interest and potential these projects held, none of them received the financial backing necessary for further development. Each of these innovators had a vision of a gyro monorail system, a transport solution that could revolutionize the way we travel. But without the necessary financial support, these visions remained confined to the prototype stage. Financial hurdles proved to be a significant roadblock, but the concept of the gyro monorail was far from forgotten. Fast forward to 2022, the gyro monorail made a comeback. After decades of dormancy, the gyro monorail re-emerged, not as a relic of the past, but as a beacon of future possibilities. This modern iteration of the gyro monorail, presented in Germany, takes inspiration from Brennan's original design. It's not a mere replication, though, but a sophisticated reinterpretation that builds on the past while looking towards the future. Funded by the European Regional Development Fund and the state of North Rhine-Westphalia, this project is a testament to the enduring allure of the Gyro Monorail concept. The updated Gyro Monorail embodies a fusion of tradition and innovation, retaining the essential gyroscopic action for stability while integrating modern advancements. It minimizes the hunting oscillation, a trait inherent in traditional trains, and allows for sharper turns, making it a potentially perfect fit for cities with complex terrains. An interesting feature of this modern gyro monorail is its gyro-stabilized system. This system adds an extra layer of safety and reliability to the monorail, ensuring it stays upright and balanced even in challenging conditions. It's a solution to the asymmetry and instability issues that plagued earlier models, like Shklovsky's Russian gyro car. Looking ahead, the potential applications of this technology are vast. It could revolutionize urban transportation, providing a fast, efficient, and more environmentally friendly alternative to traditional vehicles. Moreover, with its single rail design, it could help optimize space usage in cities, where land is often a scarce resource. The journey of the Gyro Monorail has certainly been a rollercoaster ride, with its fair share of ups and downs, but every setback, every challenge has been a stepping stone, propelling it towards a brighter future. It's been more than a century since the Gyro Monorail's conception, yet its story is still being written, its potential still being explored. While the Gyro Monorail has had a bumpy ride, its journey is far from over. The future is full of potential for this intriguing piece of technology,